As we get ready to solve the questions on this worksheet number 2, we can see that we have the empirical rule already drawn out for us, the 68, 95, 99.7 rule. And that works great if my values that I'm being asked are perfectly 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, or 1 standard deviation below, 2 below, 3 below the mean. As we get ready to run these problems, though, you're going to see that that's not going to be very helpful here. For the problems 1 through 4, we can see that our mean in each of these, I'm going to go ahead and identify this, is going to be 110 with a standard deviation of 25. So what percent of this age group will have an IQ less than 100? Well, there's a couple ways you can run it. Either by hand, by finding your z-score, so you take your value of 100, and you subtract the mean, 110, divide by 25. And if you do that, you get a z-score of negative 0.4. Then you would go into your chart and identify what that probability is. Now remember, we always want to draw our picture here, so less than 100 means that I'll be shading below wherever 100 is. If you don't want to do this by hand, you can go into your calculator and run the normal CDF that we talked about in class. Make sure that you label all your parts. So the normal CDF, because I'm running less than, my lower bound is negative 1e99. My upper bound is 100. My mean is 110. And my standard deviation is 25. And again, as long as you label all these parts, then you would get full credit on the test. And we will find that the probability of this happening is 0.3446, or if you want to turn it into a percentage, 34.46. And on this worksheet, it's okay if we don't talk about this in context, but remember, for any test or actual quiz for the AP exam, we will want to use the context of our problem. So 34.46% of this age group will have an IQ less than 100. That context would give us full credit on the test. For number 2, we want to draw our distribution here. We're looking for an IQ between 90 and 115. So we'll shade those areas that we need, and you can just label these parts. That tells the reader that you know what you're talking about. I could find the z-score for 90 and the z-score for 115 and find the probability of each of those and then subtract. Again, I'm going to go straight into the calculator here, because as long as I label the parts that I'm going to get, I get full credit. Still running normal CDF. Remember, it's CDF because it's cumulative, not just one value. In this case, my lower bound will be 90. My upper bound will be 115. My mean, not going to change, 110. While my standard deviation, also not going to change, is going to be 25. So hit enter on the calculator, paste that in. I get 0.3674. And again, if you want to turn it to 36.74%, you can. And this is acceptable for the worksheet, but for the AP test, you would want to write this in context. 36.74% of the age group have an IQ between 90 and 115. For number 3, we're mixing things up a little bit. It's asking for the 80th percentile. So instead of giving the actual value, I am going to find the inside area. So the 80th percentile will be here. It's these parts that I've covered. And remember, percentile is everything below it as well. So I can still put this into the calculator. We use the inverse normal. So second vars, if you've missed it, this is option 3 for the inverse normal. The area that we're looking for in this case is 0.80. We're going to run the mean, which is 110, and our standard deviation, which is 25. And when I plate that into my calculator, I will know that the score to be the 80th percentile would be 131. For number 4, this is a 2-part question. What numbers are going to separate the lowest 25% from the highest 75%? Well, the lowest 25%, we're going to run the inverse normal of this, and then the highest 75 will also be here, so the 0.75. So as you get ready to run these in the calculator, you want to work backwards again, so we'll run the inverse normal, just like we did before, making sure you label your parts for the area. So the inverse normal of 0.25, that's my area, with a mean of 110 and a standard deviation of 25. That's going to give me a score of 97. And then the highest 75%, be careful with this. This is how you want to do where the entire area is the 75%. Okay. So I'd run the exact same thing, inverse normal. I've just changed the 0.25 to 0.75, and that should give me a score of 127. As we move to number 5, we have adult men of the Dinaric Alps have the highest average height of all regions. The distribution of height is approximately normal with a mean height of 6 foot 1 inch or 73 inches and a standard deviation of 3 inches. Find the 40th percentile of the height for the Dinaric Alps distribution for men. So if I'm finding the 40th percentile, remember I'm going to use the area, and if I'm having the area, that means I'm running an inverse normal. Label our parts. The area is 0.40. My mean in this case, and because we talk about our standard deviation in inches, we're going to do the same thing with our mean. So we're going to use 73 inches and a standard deviation of 3. And as we put that into the calculator, you see that the 40th percentile is a man that is 72 inches tall. And again, for the worksheet, it's fine just to put this, but we would want to put this in context if this were a test or a quiz. Okay. For number 6, what percentage of men have a height greater than 74? Well, we make sure we shade this correctly. Greater than would be above. So as we're labeling this, again, they give us the actual value, so we're just going to use a normal CDF. And it's CDF because we want the cumulative value. The lower bound in this case would be our 74, while the upper bound will be positive 1E99. The mean is 73, and our standard deviation is 3. So when you type this in, you should get 0.3707. If you want to turn that to a percent, you could call it 37.07%. For number 7, what percentage of men have a height between 70 and 78 inches? So between these two values, 70 and 78, I would run my normal CDF. My lower bound will be 70. My upper bound will be 78. My mean is 73. My standard deviation is 3. Make sure you label all these parts. When you do this, you can find that your percentage will be 0.7938, or if you want to make it a percentage again, 79.38. So if the average height of adult men is 69 inches, what percent of the adult men in the Dinaric Alps are taller than the average American man? So in this case, we're looking for the value that is taller than this. So we're just going to run our 69%, or 69 as our z-score. So that is going to be our lower value. So normal CDF. Then we're going to say lower bound, negative 1E99, upper bound 69, mean of 73, standard deviation of 3. And when you run this, you get 0.0918, or 9.18% of the generic men. Or I'm sorry, adult men in the generic Alps are taller than the average American man. Finally, what would be the minimum height of a man in the generic Alps that would place him in the top 10% of all heights? Well, top 10% would be here, but remember for z-scores we run below, so we're going to use 0.90 as our area. Because I have area, it's going to be an inverse norm. We'll type in 0.90. My mean is 73. My standard deviation is 3. When you run this, you get 76.84. You can round that to be 77 inches if you would like. For number 10, we have the length of a pregnancy for the Asian elephant has an approximately normal distribution with an average length of 609 days and a standard deviation of 31 days. So how long did the longest 5% of all elephant pregnancies last? Well, the longest 5% will be up here, but remember, z-scores, we have to run the area of everything below. So we'd run an inverse norm. My area will be 0.95. The mean in this case is 609, and my standard deviation is 31. Well, when you run this, you get the length of the pregnancy would be 660 days. So what percent of elephants will fall between 600 and 615 days? Because they're giving me the actual days, I run a normal CDF. My lower bound will be 600. My upper bound will be 615. My mean is 609. Standard deviation, 31 days. Make sure you're labeling each part. And as you run this, you should get 0.1894. If you want to turn it to a percentage, it'd be 18.94%. For 12, the shortest 20% of all elephant pregnancies last fewer than how many days? So I'm looking for the area of 20%. So it'll be an inverse normal. Area 0.20. Mean of 609. Standard deviation of 31. And when you run this, you get the shortest 20% of pregnancies last 583 days. For this last one, it says the middle 50% of all data. Okay, so I'm looking for this middle 50%, or remember we can find that by running our 25% inverse norm and our 75 and then subtracting those two values. So if I run the inverse norm, 0.25 as my area, 609 is my mean, 31 is my standard deviation. I get that to be 588 days. Then if I come back and run the inverse norm, 0.75, because again, that'll be my middle 50%, subtracting those two things. 609, 31. Still got to label these parts. Don't be lazy. This is the area. I will find that I get 630 days. So the middle 50% of my data will fall between 588 days and 630 days.